Good morning, Ms. McEwen students. This is Mr. Weissman, and today I'm going to be giving you a fun experiment that you can try at home. And these are the materials that you're going to need. The ball, of course, is optional. And the activity is making your own compass. Now, a compass looks like this. It points different directions out, north, south, east, and west, using a compass rose, and it works by magnetism. Here we have sort of like a needle which is magnetized at one end, and it points to the magnetic north. Now, our magnetic north is changing on Earth at quite an alarming rate, and I have another video that will follow this one that you can see how important the magnetic poles of the Earth are. But if you could imagine that this ball is the Earth, there would be like a invisible magnetic bar magnet that would go through the north and south pole of the Earth, and it's magnetic. Now, from one side of the ball to the other side would be the Earth's diameter. That's 8,000 miles. So from where we are to the center of the Earth would be around 4,000 miles. So a lot of things can disrupt a compass, such as a magnet near it or something of that nature. But today's experiment's really fun, and this is what you need to do the experiment. You need a bowl with some water in it, a leaf. I'm going to zoom in on this leaf so you can see it. One shaped like that works really well. Don't pick a poison ivy leaf. And then a needle. Okay, so to make your compass, the first step is to take your needle, and you're going to need a magnet, maybe off your refrigerator or something of that nature. And you're going to take your needle and you're going to rub the needle on the magnet. And what that does is it magnetizes the needle. So I'm now rubbing the needle on the magnet, and you can see how that's working out here. I'm trying to hold the phone at the same time. Rub, 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 and try to get it on different sides. And you're only going to do just the point of the needle. You don't have to do any other part. Just rub it back and forth for about 30 seconds or so, and it will magnetize it. Then what we're going to do is we're going to create the floating boat compass of science. So you're going to take your leaf and you're going to kind of fold it so that it floats well on the water. Kind of folding it up like in half, sort of. That's why I chose this shape of a leaf. We're going to float it on the water. Okay, now we have our needle is going to ride on the boat like that. And you see how it's spinning. It is spinning to face north, and eventually it will stop after a little bit of commotion here. And look at that. It is facing north. So why is it facing north? Well, if you have ever had two magnets, you will see that the north and north poles of two different magnets attract each other. Now, like charges repel, but opposite charges attract. But anyway, the reason I had mentioned about the Earth's diameter before is because you don't want a magnet that's close to yours. Look how my magnet here is affecting the needle here. See, here we have it's attracted to that. So I'm going to put that away, and now we can see, after it settles down, the magnetic compass will point to the north. Fun experiment to try at home. And what you can do is you can compare it to the compass that's probably on your mom or dad's phone. You have a compass on a phone. So you can compare it and see how accurate it is. Well, I hope you enjoyed the floating compass experiment, and good luck.